This is half past paper, week 28 for the higher tier, non-calculator this week. Let's get into it. Question number 1. Solve 7x minus 27 is less than 8. Now you would do this in the same way that you would solve an equation if it had an equal sign. So I'm going to do my dotted line here. Some students like to change it to an equals and then put it back to an inequality, but I often find that students forget to put it back. So I personally don't change it, but that's up to you. We're going to start by adding 27 to both sides. Reason that we're doing that is to get rid of the minus 27. To solve, we just want that x left on its own. So I'm getting that x on its own by getting rid of the minus 27, adding 27 to both sides. Now I've got 7 lots of x is less than 35. But I don't want 7 lots of x, I just want x. So to get that, I'm going to divide this side by 7 and also divide this side by 7. So x is less than 5. That's my answer. We need the inequality on the answer line. You can't just put 5 on the answer line because it's important that x needs to be less than 5 in order for 7x minus 27 to be less than 8. Question number 25. A delivery company has a total of 160 cars and vans. The number of cars to the number of vans is in the ratio 3 to 7. So when I see ratio like this, I like to lay it out 3 parts here to 7 parts here. 6, 7, and these are your cars, they would fit on these lines, and these are your vans, they would fit on these lines. Each car and each van uses electricity or diesel or petrol. An eighth of the cars use electricity, 25% of the cars use diesel, and the rest of the cars use petrol. Work out the number of cars that use petrol. So first let's work out how many cars and how many vans we have. We know that all of this is equal to 160. So I need to share the 160 equally over those lines. And I've got 10 lines, 1, 2, 3, and 7 on the other side. So I've got 10 little lines there. So 160 divided by 10 is 16. So we know there are 16 cars and vans, 16 vehicles, let's say, on each of these little lines, which means that there are 3 lots of 16 to work out the number of cars, and 7 lots of 16 to work out the number of vans. So cars, 16 times 3, 3 times 6 is 18, and 3 times 1 is 3, add that 1 is 4. So there are 48 cars. And we could do 7 times 16 to get the number of vans, but I'm interested in cars here, so that's what I'm going to go with. 48 cars. Now an eighth of the cars use electricity. So an eighth of 48, to find a fraction of a number, we divide by the bottom and then multiply that by the top. So 48 divided by 8 is 6, times that by 1 is just 6. So an eighth of 48 is 6. So 6 use electricity. 25% of the cars use diesel. So 25% of 48. Now remember, 25% is a quarter. So we're going to half it and half it again, or divide it by 4, and that is 12. So 12 use diesel, and the rest of the cars use petrol. So I've got 12 add 6, which is 18. 18 cars that we've worked out use electric or diesel. So the rest of them, 48, take away 18 is 30. So there are 30 cars that use petrol, and that would be your answer there. And that was 5 marks for that one. Question number 27. Here is a regular hexagon and a regular pentagon. Work out the size of the angle marked X. You must show all your working. So a 5-sided shape, a pentagon, to work out how many degrees in total we have inside the pentagon, we do the number of sides, which is 5, take away 2, times by 180. So the formula to work out how many degrees are inside a shape is the number of sides, take away 2, times by 180. So in this case, we've got 3 lots of 180, 180 times by 3, which is 540. So 540 degrees in a pentagon. Now, because it's regular, all of those angles inside, all 5 angles, are going to be the same. So I'm going to do 540 divided by 5. 5 goes into 5 once, 5 does not go into 4, so we've got to carry that 4 over, and 5 goes into 40 8 times. So each of these angles inside is 108 degrees, because it's regular and it adds up to 540. Now on this side we have a hexagon. So again, if we want to know how many degrees fit inside that hexagon, we do the number of sides, which is 6, take away 2, and times it by 180. So 4 times 180, and you can do it like this if you need to. 4 times 0 is 0, 4 times 8 is 32, and 4 times 1 is 4, add the 3 is 7. So I know it needs to add up to 720 in total, and we've got 6 equal angles inside that shape. So 720 divided by 6, 6 goes into 7 once, remainder 1, 6 goes into 12 twice, and 6 goes into 0, 0 times. So each of these angles here is 120 degrees. Now if we come to that point where x is, I know that angles around a point, all the way around here, need to add up to 360. So I've got 120 and 108 so far, and that makes 228. I then want to take that away from 360. So 360 take away 228. If you've got more on the floor, you're going to borrow from next door. So 10 take 8 is 2, 5 take 2 is 3, and 3 take 2 is 1. So the angle there, x, is going to be 132 degrees. That was 3 marks for that one. Question number 29, here are two cubes A and B. Cube A has a mass of 81 grams and cube B has a mass of 128 grams. Work out the density of A to the density of B, and we want that as a ratio. Give your answer in the form A to B, where A and B are integers, so whole numbers. So I'm going to start by drawing the triangle for density, formula triangle, density, mass, volume, like that. We cover up the thing we want to know and we do the sum that is left behind. So if I would like to work out the density, I'm going to need to do mass divided by volume. So I'm going to need the mass, which I've got, 81 grams and 128 grams, but I'm going to need the volume, and at the minute I don't have that. These are cubes, so to work out the volume, we need to do the length times the width times the height. And because they're cubes, we know that all of the length, width and height are the same. So for cube A, it's 3, 3 and 3, and for cube B, it's 4, 4 and 4. So the volume of A is 3 times 3 times 3, which is 9 times 3, which is 27 centimetres cubed. And for B, the volume is 4 times 4 times 4. 4 times 4 is 16, times that by 4 is 64 centimetres cubed. Okay, so in order to work out the density of A, that's going to be the mass of A divided by the volume of A. So the mass of A is 81 divided by the volume of A, which is 27, and 81 divided by 27 is 3. So the density is 3 grams per centimetres cubed. Now the density of B is going to be the mass of B divided by the volume again. So the mass is 128 divided by the volume, which is 64. And 128 divided by 64, well, that fits in 2 exact times. So 2 grams per centimetres cubed. Now they want that as a ratio, the density of A to the density of B, and that's going to be 3 to 2. Give your answer in that form. A and B have to be whole numbers, and we've got that. So your final answer there is 3 to 2. Question number 9. A cube is placed on top of a cuboid as shown in the diagram to form a solid. The cube has edges of length 4. The cuboid has dimensions 7 by 6 by 5. Work out the total surface area of the solid. So the surface area is the area of all of the faces added together. And that's going to be all of this around the outside here, the front face, the side face, the back, this side, and the underneath. But it's also going to be the surface area of this face. However, this bit in the middle here, we're not going to count because we would not have that bit on the outside of the shape, so it does not form the surface area. Okay, so let's start by finding the surface area of the faces that we've got down here. Now on the side, we've got 5 times 6, which is 30, and we would have that on the other side as well. So I'm going to times that by 2 and get 60 for the left and the right hand side. For the front, it's 7 wide and 5 tall. 7 times 5 is 35, and again I have that face on the back. 35 times 2 is 70. Let's circle all the ones I want to include. I've then got the underneath, and the underneath is 7 times 6, which is 42. Now I have 42 on the bottom, but the 42 on the top is disrupted by the fact that this cube is sat on it. So the top face here is 42, but we're going to subtract 16 because this face in the middle is 16, 4 times 4. So 42 take away 16 is 26. So 26 is going to be the area of this part that is around the outside. So we've got 42 for the bottom, but only 26 for the top. And then for the cube, I've got 4 times 4, 16, for all 5 faces that are visible. The base is not visible, it's inside the shape. So 16 multiplied by 5 is 80. So we're adding all of those values together. I've got 80, add 70, add 42, add 60, add 26. 1, 2, 3, 4, 5 of those. Yeah, that's fine. So that's 150. Let's do these guys is 86. And then let's add those together. So 150, add 42 is 192, add 86 is 278. Now the surface area, if it wasn't down here, would be in centimetres squared because it is area. So 278 is your answer there. Lots and lots of faces, lots of marks you could gain there by working out the various faces. So hopefully that makes sense. Hopefully we're happy with that. Okay, question number 11. Cormac has some sweets in a bag. The sweets are lime or strawberry or orange. In the bag, lime to strawberry to orange is in the ratio 9 to 4 to x. Cormac is going to take at random a sweet from the bag, and the probability that he takes lime is 3 out of 7. So lime is this first section. So we don't know how many sweets there are altogether, because we don't know how many orange there are. We don't know the ratio for orange, and we're not told how many there are altogether. But we do know that lime needs to be 3 out of 7. But I can see here that lime is 9 parts. So if I want to make this fraction, out of 9, I would need to multiply the top by 3 and also multiply the denominator by 3 to keep it equivalent. So it needs to be 9 out of 21. Now 9 and 4 makes 13 parts. What do we need to add to 13 to make it up to 21? It needs to be 8. So the only ratio that would make sense here is 9 to 4 to 8, so that it adds up to make 21. So work out the value of x. Well, x has to be 8 because 9 out of 21 is equivalent to 3 out of 7. I think that makes the most sense to me. It seems bizarre that one's 3 marks to me, but there we go. 8 is the missing answer there. It's just using equivalent fractions and making sure that that would add up to 21 if it's 9. Okay, question number 13. A very tricky one, this one. A right-angled triangle is formed by the diameters of 3 semicircular regions, A, B and C, as shown in the diagram. Show that the area of A equals the area of B, add the area of C. So let's call this side A, this diameter of circle A. Let's call this bit B, and let's call this bit C. Okay, if I want the area of this, I know it's pi r squared divided by 2, because I only want half a circle, and the area of the circle is given by pi r squared. That is the formula for the area of a whole circle. But my radius would be a half of A. So therefore, the area of A, let's do it down here, A equals B, add C. That's what they're asking me to show. So that's going to be pi times a half A squared divided by 2 equals pi times a half B squared divided by 2, add pi times a half C squared divided by 2. So that is what they're asking me to show. Okay, now let's work with this. This is an equation, so we can multiply everything by 2 and get rid of all of those fractions. So I'm left with pi times, let's also square this. This will be a quarter A squared, because you're doing a half A times by itself, and a half times a half is a quarter, equals pi times a quarter B squared, add pi times a quarter C squared. And then we're going to divide everything by pi. So dividing everything by pi, I get a quarter A squared is a quarter B squared, add a quarter C squared, and then multiplying everything by 4 gives me A squared equals B squared plus C squared. And we know that that is true from Pythagoras. A is our longest side in this triangle, so therefore Pythagoras So yes, true. Quite a tricky one, that. So we had to get down to Pythagoras at the end to show that that was definitely correct. Okay, question number 15. A, B and C are 3 points such that A to B is 3A add 4B and A to C is 15A add 20B. Prove that A, B and C lie on a straight line. Well, A to B is 3A add 4B and A to C is 15A add 20B. So how would we show that that lies on a straight line? Well, all we need to do is show that it's a longer version and show that it's a multiple of that. So we've got C up here. So 15A add 20B, if we take 5 outside the bracket here, we get 3A add 4B. Therefore, it's parallel and starting in the same place, so makes a straight line. If one vector is a multiple of another vector, if it's just been multiplied by a number, then it is going in exactly the same direction, it's just longer. So there we go. D, E and F are 3 points on a straight line such that D to E is 3E add 6F, and E to F is minus 10.5E minus 21F. Now this is a little bit tricky. If it's negative though, it's going to be going back in the other direction. D, E, F are all on the same line, so it's not going to be a continuation. E to F, we're going back this way. So from here to here, it's minus 10.5E minus 21F. In which case, let's look at the difference. So this bit here is 7.5E, if we're going in this direction, add 15F. So you can see that then going in this direction, it would be 10.5E add 21F, and going back again would be minus 10.5E minus 21F. And we're looking at the ratio of this bit to this bit. So we can look at either parts because the ratio of 7.5 to 3 will be the same as the ratio of 15 to 6, but 15 to 6 is much nicer because I've got whole numbers there already. So I'm going to write the ratio as 15 to 6. They're both in the 3 times table, so I'm going to write that as 5 to 2, and that would be your answer there. Another tricky question there, but 5 to 2 would be your answer. Okay, question number 17. Y is directly proportional to the square root of t. When it's directly proportional, we're writing it on a line like that. Can't solve equations with fish in them, so we change it to an equals and a k. Now we're given a pair of values always, so 15 equals k times root 9. 15 is k times 3. Dividing both sides by 3, we get 5 equals k. We then go back to that equation and we now know what k is. We know that connecting factor between the two values, so y equals 5 lots of root t. Now let's have a look at the other statement we're told. T is inversely proportional to the cube of x, so t equals k over x cubed. We're then given the pair of values, 8 equals k over 2 cubed, that's coming from the values we've been given here, and 2 cubed is 8. So 8 equals k over 8. Multiplying that up, I get 64 as k. Going back to the second thing I wrote, I can fill that in and I can write t equals 64 over x cubed. So I've got two formula here. I'm then asked to find a formula to y for y in terms of x. So I don't want a t in it, I want an x in it, in which case we need to take this and put it here. So I'm going to write y equals 5 root 64 over x cubed. Now you can simplify that further. Y equals 5 times 8 over root x cubed. I'm going to do that. And that's going to be y equals 40 over x cubed rooted. And I would leave it like that. There we go. A formula for y in terms of x. Question number 19. Solve 1 over 2x minus 1, add 3 over x minus 1 equals 1. Give your answer in the form p plus or minus root q over 2, where p and q are integers. Now this is giving me quadratic formula vibes, but let's just see where we get to. So I'm going to do this by doing this. We multiply in that picnic bench shape Upside down picnic bench, that's what a lot of people call it. So if we're adding fractions or taking away fractions, let's just do this. We want to make the denominators the same. What we multiply the bottom by, we multiply the top by, and you end up doing this multiplication grid like this. And it's the same with algebraic fractions. So I'm going to do x minus 1 over 2x minus 1, x minus 1, add, it is an add, isn't it? Yeah, 3 lots of 2x minus 1 over 2x minus 1, x minus 1 equals 1. So I'm going to make this fraction all over that common denominator of 2x minus 1, x minus 1, and on the numerator I've got x minus 1, add, and I'm going to times this out, 6x minus 3, and that equals 1. So I'm left with 7x minus 4, and I'm going to multiply this denominator up to the other side. So if I times by that denominator, it's going to go up here. So I've got one lot of 2x minus 1 multiplied by x minus 1. Let's expand this out. So 7x minus 4 equals 2x squared minus 2x minus x plus 1. And I want to make this equal 0 because it's a quadratic, and that's how we would go about solving it. This makes minus 3x, and then I'm taking 7x away from both sides. If I've got minus 3x here, and I'm taking away another 7x, I'm going to go down to minus 10x. And then I also need to add 4 to get rid of that minus 4, and adding 4 here gives me plus 5. Now, this is not going to factorise, and I know that this is not going to factorise because I'm asked to give my answer in this format, and if it factorised, I would not get a third. So this is making me think I'm going to use the quadratic formula, minus b plus or minus the square root of b squared minus 4ac all over 2a. Now this is a non-calculator paper, so that's why we're asked to leave it in this format. A is 2, b is minus 10, and c is 5. So this is going to be 10, because minus minus 10 is just 10, plus or minus the square root of, minus 10 squared is 100, minus 4 times 2 times 5, all over 2 times 2. And that becomes 10, plus or minus, this bit here makes 40. So the square root of 60 over 4. Now we're not quite done, because the square root of 60 can be simplified. The square root of 60 has a square number factor of 4. So root 4 root 15, which is 2 root 15. So this is 10 plus or minus 2 root 15 over 4, and everything is even. Everything can be divided by 2. So my final answer is 5 plus or minus root 15 over 2. And that is in the format that they've asked us for at the top. Another tricky question. Question number 21. The diagram shows 3 circles, each of radius 4. The centres of the circles are A, B and C, such that ABC is a straight line, and A to B, B to C is 4. So this is 4 centimetres, and this is 4 centimetres. Work out the total area of the 2 shaded regions. Now if we take that B up to here, and down to here, and we could even go across there if we want, like this, we can split this circle up into 6 equal triangles going round it, and that is going to be an equilateral triangle because it's 60 degrees. I know the radius here is 4, this is 4, this is 4, it's all 4. So those are equilateral triangles, 60 degrees, and they all have side lengths of 4. So I want to look up close at that equilateral triangle and the sector that is made with the extra bit of area here. So to do that, I'm going to think about the fact that I've got a circle, so pi times 4 squared, and it's split into 6 equal sectors, so divided by 6. So that is 16 pi over 6, which is 8 pi over 3. That is the area of the whole sector, like this. Now the area of the triangle, we're going to use half AB sine C. So this is 60 degrees, 4 and 4, so half times 4 times 4 times sine 60. And you would be expected to know that that is root 3 over 2. Now, exact trigonometric values, let's just do a quick side note. I like to remember this triangle, 60 degrees here, 30 degrees here, 90 degrees here, 1, 2, root 3. And then if you want sine 60, we know that sine is the opposite over the hypotenuse, so root 3 over 2. So half times 4 times 4 times sine 60 is going to be 8 times root 3 over 2, and that is 4 root 3. 8 divided by 2 is 4. So 4 root 3 is the area of your triangle, 4 root 3 like that. Therefore, if you just want the slither here, this little section, it's going to be 8 pi over 3 minus 4 root 3. Okay, now let's look more closely at what they've asked me for. They've asked me for this section here. Now that section, that shaded bit, and we're going to have to double it because we've got one at the bottom as well, is made up of one sector minus 2 of those slithers. So to find that bit there, I'm going to do my whole sector, 8 pi over 3, minus 2 slithers. And we know that a slither is given by this. So 2 lots of 8 pi over 3 minus 4 root 3. And then we've got 2 of those. So after I'm done with that, I'm going to double the whole thing. So let's just sort this out. Let's make it a little bit nicer. 2 lots of this is going to be given by 16 pi over 3 minus 8 root 3. And I'm taking that away from 8 pi over 3. So I'm going to do 8 pi over 3 minus this, and then I'm minusing this one, which is going to add it on. So let's go down here. I'm going to run out of room. It's going to be minus 8 pi over 3, add 8 root 3. And then I'm doubling that because I've got 2 different sections. I've got the bit at the top and the bit at the bottom there. So my final answer, I'm actually going to flip it round because I want the positive bit first, is going to be 16 root 3 minus 16 pi over 3. There we go. What format will we asked to leave it in? No, that's it. Give your answer in terms of pi. So that is it. A very, very, very tricky paper, I think. Hopefully you enjoyed that. If you've got any questions about where any of it came from, please let me know in the comments. But that was a hard one this week. I hope you enjoyed it, and I will see you guys next week for week 29.